Okay, let's do our last set of problems here, and on these we're going to do them just a little bit different. What we're going to do is find the area of the shaded region, and then we'll talk about how to find the probability of that shaded area. First one is we've got a circle with a sector shaded on it. That sector is 70 degrees out of the 360, okay? How do we find the entire circle? We need 70 out of 360 of that circle, so let's see what we do here. We're going to look at the shaded area. Okay, the area of the circle is pi r squared. R is 5. Pi times 5 squared is 78.54. That's the entire circle. I don't want the entire circle. I only want 70 degrees of the entire circle. What part is that? Well, we're going to set up a proportion. 70 is to 360 as x is to 78.54. 70 degrees of the circle is to the entire circle as the area of our sector is to 78.54, the total area of our circle. So we simply do the cross multiplication. We come up with 70. Let's put this as an x here so you know we're multiplying. 70 times 78.54 divided by 360. When you do that, the area of that shaded area is 15.27. Now, how in the world would we come up with a probability? Well, the probability would simply be, oh wow, 70 over 360, or 15.27 divided by 78.54. Now, they should come up with the same number, shouldn't they? If we did our work right. If they don't, well, we start over. I don't want to do that. Okay, for the first one, we come up with a percentage of 19.44%. 15.27 divided by 78.54. Oh wow, look at that. 19.44%. Yes. Colonel used to say on A-Team, I love it when a plan comes together. Now let's look at the next one. I want to find the area of this shaded portion right there. And then we'll look at finding the probability. The area of that shaded portion is going to be the area of the circle minus the area of the square divided by 4. Now, why in the world are we going to divide that by 4? We're going to divide it by 4 because there's 4 sections and we want one of them. What if we wanted 3 of them? We would divide it by 4 and multiply by 3. We're just dividing by 4, multiplying by 1. That's going to get us the same thing. So let's do what we got. Area of the circle is pi r squared. R is 4. Pi times 4 squared is 50.27. Okay, we're good there. Now the square. What is the area of the square? Well, the entire diagonal is 8. What's one side? That's a special right triangle. What do we know about that triangle? This right here is 45 degrees. This right here is 45 degrees. This side is 8 divided by the square root of 2. This side is 8 divided by the square root of 2. Well, we multiply 8 times the square root of 2 by itself, and we get 32. That would be 64 divided by 2, which would be 32. So we're going to come back up here and do our equation. We take the area of the circle minus the area of the square. We divide by 4. We come up with 4.57. Okay, that's how much is there. Now, how would we find the probability? The probability would be 4.57 divided by the entire area of the whole thing would be 50.27 equals, let's go there, 4.57 divided by 50.27 equals 9.1%. Okay? 9.1% is what that takes up. Alright? Study that one. This one is interesting. We want to find the area, and then I'll let you figure out how to find the probability. Okay? Or we'll do it down here on the side. We have a circle. And we have a sector cut out of it, and then they come along and they connect these 2 points out here of the central angle to create a secant across there, and they say, oh, cut that triangle out of that thing, now we want that shaded area. Thank you so very much for making my life complicated. Had it really good. I could have found the whole area of that divided by 3 and been done home free, right? No, they got to come in there. So what we're going to do is we're going to take the area of the circle, and this 120 is 1/3 of that thing, isn't it? Why is it 1/3? The entire circle is 360. 120 is 1/3 of 360. So I'm going to take the entire circle, I'm going to divide it by 3 to get that third, and then I got to somehow get that triangle out of there, and we done. So let's go there. Area of the circle. It's that, isn't it? Okay? Come up with it. Pi r squared. R is 6. Pi times 36 is 113.1. The sector that we want, that 120-degree sector, is A is the circle divided by 3. That's 113 over 1 divided by 3 is 37.7. So this 120-degree sector, 1/3 of that, is that. Now we've got to go find a triangle. Well, let's look at that triangle. We're going to turn it around and put it down here. That's 120 degrees. This hypotenuse is 6. If that's 120, I got 60 left on that. That's a 30, that's a 30. I'm going to drop an altitude, which is going to cut that thing in half. Okay? And that's a 30, 60, 90 triangle. The hypotenuse is 6. The short side is what? Special right triangles. You got to look at them. What is it? It's 3. What's the long leg? 3 times the square root of 3. Great, I got it. Now, what's the area of a triangle? Base times height divided by 2. What's our base? Well, that would be this whole thing here. Well, that's 2 times 3 times the square root of 3, which comes up to be 10.39. What's our height? That's just 3. So the area of the triangle is 10.39 times 3 divided by 2, which is this. Got it? So what's the area of the shaded part? Area of the shaded part is area of our sector in our circle minus the area of the triangle. So therefore the shaded part equals 22.11. Now if I wanted the probability of hitting that, I would have to take 22.11 divided by the entire area of the whole circle. What is that? Right there. 113.1. And that equals 22.11. 113.1. 19.6%. Okay? I encourage you to study these at length. These are not the most complicated. These are not the most challenging. They're not the least. Try to get in the middle so that you could have something to work with. And that's area, geometric probability, area of all polygons that we've done in circles. And we're through with that area stuff.